So here we have another one of these number sequence problems, and we're given the first few numbers in the sequence, we're asked for the next few, and then we're asked to come up with a rule, and then we're asked to use the rule to figure out what the 100th number in the sequence is. So the first thing we have to do when we're looking at our rule is what are the differences between consecutive terms. Oh, well, let's get our next three. It's 50 to 47 is -3. 47 to 44 is down 3. 44 to 41, down 3. We can use that to fill out the rest here. This would be 38, 35, and 32. And of course, for every 3 we go down, we're increasing 1 over here. So it's a decrease of 3 for every increase of 1. So the rate of change here is 3 to 1. So we write our rule. That means that y equals some variation on 3x. But then we have to look and we'll see that, or negative 3x, sorry, negative 3x. But then we have to look and see if that actually works. Well, 1 times -3 is -3. 2 times -3 is -6. 3 times -3 is -9. And 4 times -3 is -12. And you can see that this rule as it is, -3x, is not giving us outputs anything near what we want. Let's see how far off we are. Let's see. Get my calculator out here. So let's see. We'll go 50 minus -3, or 53 off. So I would have to add 53 in this case. 47 minus -3 is, -6, sorry. So from 47 minus -6, 53, I would have to add 53 here. See, 44 to -9, 44 minus -9, 53. I'd have to add 53 here. I think we see a pattern shaping up. And if I wanted 41, but I got -12, 41 minus -12 is 53. So in every case, my rule -3x gives me the wrong output, but it's consistently 53 units off. So to fix that, I'm just going to add 53. And then I can use that to find out what the 100th number in the sequence is just by plugging 100 into our formula. So y equals -3 times 100 plus 53. So let's see. Y equals -300 plus 53. Let's see, if I'm 300 down and I go up 50, I'd be at -250. So another 3 would be -247. So remember the process here. We start out, we just listed our numbers in a table form. We looked at what the consecutive differences were. And notice this time we're going down, so the differences are negative. And we see, well, that for every 3 units we go down 1 over here. So for every 1 unit we go up here, we go down 3 over here. And so that means that our rule for y will be y equals -3x, or some variation on that rule. Then once we know the rule, we're going to test it out here, y equals 3x, and we see what our outputs would be if the rule was just -3x. So we get -3, -6, -9, -12, and you see those differences of 3 or -3 there. We're going down 3 each time. But we see that those are consistently off, right? These aren't the outputs we want. The rule is wrong. So we have to adjust it. And we just check, well, if we have this and we want that, what do we have to add to this or subtract from it to get what we want? And so from -3 to +50 was a +53. And then from -6 to 47, it's +53. We check the others, it's consistently +53. So our rule must involve a +53 at the end. Then if we want to get any given output number for some, if I want to find out what the 100th number in the sequence is, so what do I get when I input 100 into this rule? So I just plug 100 in and work it out. I could work the other direction as well. I could say, well, if I want to test to see what input was given to get some given output, then I would just replace y with the output, and then I have to solve the equation and work backwards to find out what number in the sequence that was, or what was the input variable. All right, and that's how we find the rule for a sequence of numbers from the sequence itself.